Hey everyone. Today we are working on calculating potential energy. This is easier than calculating kinetic energy. That's definitely the toughest one that we look at. But we'll run through each of our formulas for now. Okay, so remember this is the formula for velocity. Think for a second, what does each part of this mean? So the V stands for velocity, the D stands for distance, and the T stands for time. So in order to find velocity, we are doing our distance divided by our time. This is it written out, and a reminder that the units for velocity are meters per second, or we can abbreviate that as m/s, meters per second. All right, kinetic energy, our formula is Ke equals 1/2 mv squared. You never have to memorize this formula, don't worry about that at all. But it's important to know the formulas because that can help us remember what these different measures depend on. So in this case, kinetic energy, it changes with mass because mass is a part of that formula. So if we have a bigger object, a more massive object, then the kinetic energy is going to be higher. And it also increases with speed or velocity. And so if something is moving faster, it has more kinetic energy. It seems like you guys all got that, and that is great. The units for kinetic energy, remember, are joules, or J, and that's a capital J. All right, so this is our potential energy formula. So remember we talked about last week, I think, that potential energy is a measure of an object's stored energy. So if I hold my phone up, it has some potential energy because it will fall if I drop it. If I stretch out a rubber band, that has potential energy because there's energy stored in it being stretched. If I were to let go, we know that it would move. We're going to mostly just focus on the potential energy that something has because of its height. So when things are higher up, they're going to have more potential energy because they have the potential to fall further, faster, that kind of thing. And so the potential energy formula is PE equals mgh. That's mass times gravity times height. And we can remember that if you know the hospital mgh, I feel like that's an easy way to remember the potential energy formula. You don't have to memorize it, but it can be helpful to just have those words in your head. So potential energy equals mass times gravity times height. The M stands for mass. We know that already. The G stands for gravity. We haven't used that yet. But for gravity in this class, we're always going to use 10. That's how fast something accelerates because of gravity. You don't really need to know the details of that yet. You'll get more into that in physics. But we'll always be substituting 10 for G. So anytime you're seeing potential energy formula, you want to substitute the 10 for G. And then H stands for height, so how high something is. And remember, when something is higher, it's going to have more potential energy because it can fall further. All right, so based on that formula, we saw that PE, potential energy, increases with mass, and it also increases with height. The units for this are easy to remember because it's the same as our kinetic energy. It's joules, or J. All right, so let's do one practice formula, and then we're going to practice this more in class. So imagine you're holding a 1 kilogram object 2 meters in the air. We're trying to calculate its potential energy. So this water bottle is probably about a kilogram because it has some water in it. A kilogram is about 2 pounds or so. Let's imagine that I'm holding it 2 meters in the air. I want to calculate the potential energy of this water bottle if I'm holding it 2 meters up. So all the key information is in this little paragraph, and then I wrote it out here. So remember, our formula is PE equals mgh, mass times gravity times height. The mass listed in this problem, it said 1 kilogram. So I put that here. M equals 1 kg. G is gravity, and remember we said we're always going to use 10 for gravity in this class. Gravity is always going to be 10 here. And then the height that this was listed at was 2 meters, and that's about 6 feet. We always want to use meters for the heights in these problems. All right, so it's pretty straightforward. I'm going to substitute this 1 in for the M here, the 10 in for the G, and 2 is the height, so I'm going to put 2 where the H is. Those are all substitutions that I'm doing. it looks like that. And so that's 1 times 10 times 2. I bet you can all do that in your head. What is the potential energy for this water bottle if I hold it up at 2 meters? The potential energy is 20 joules. All right, so hopefully you got that same thing. You can do the form that is attached to this. It's not going to ask you to do any calculations. We'll practice that a little bit more in class. I'll see you there.